so how you guys doing today? Good, good, perfect. So we're almost done with chapter the 17. Okay, so we're gonna finish up and we'll move on to the chapter 19. Okay, so make sure we're skipping chapter 18. Okay, so we're gonna finish up the chapter 17 and then we'll move on to chapter 19. Skipping chapter 18. Okay. So the last part is the also another oxidation here. Phenol over here. Okay, and then I'm gonna treat this one. Okay, I'm gonna treat it with the sodium dichromate. Okay. And then what happens to here is very strong oxidation, which happened to the phenol here. So what we're gonna do is you're gonna make the benzoquinone. Okay. Okay. So this is very strong oxidation. They even oxidate this part here, but also this part over here. Okay. So we ending up having benzoquinone here, and then you can actually do it kind of in the other way. What you can do is you can use the tin 2 chloride over here, and then we're actually gonna do some reduction over here. So we'll go back to the liver of so it will become hydroquinone. So you can actually do a bit of oxidation reduction quite a here, but you can treat this one again with the sodium chromate. I can try to. So just if you can memorize this one, would be great. So this is the last part. There's some more, but it kind of overlaps with the chapter 19. So for the last part of the chapter 17, if you can get this one right, should be good to go to the next chapter. So the oxidation reduction, we'll see some of this maybe some in the next chapter as well. So I'll move on. Okay. All right. So the chapter 19. Okay, once again, we'll skip in chapter 18, chapter 19 over here. This is about the aldehyde, and the ketones. We're gonna do two here. So I can show you some of the so this is the coenzyme. We call this PRP. It's because it is a pyridoxal phosphate, so we call this PRP. This is a coenzyme because it's not a protein, but it helps to the protein, help the enzyme protein to do some metabolism in the body. Okay, so this is a good example of what the aldehyde. So this is quite important. All right. Okay, so so this is the hydrocortisone. This is obviously looks like a hormone, right? Steroid hormone. It helps the metabolize the fat and protein and carbohydrate. So this is also a good example of ketone. Okay? So this is the something why we learning this chapter, which is a highly important compounds are informed with the aldehyde and ketones. All right, so let's start with the nomenclature. How are you gonna name this compound? Okay, so we have maybe this. So only thing you really have to do is that this part is 2 carbons here, right? So it'll be ethane, right? And then if you have a carbonyl groups with the hydrogen, that gives the this aldehyde form. Okay. So whenever you have an aldehyde form, we're gonna copy the first 2 syllables over there, and we can just call this ethanol. Because you have a 2 carbon based, and so it's ethane, right? But with the carboxyl group and hydrogen, that makes the aldehyde form. So we try to put Al instead of just E, so it becomes methanol over here. So if you have this one instead, okay? So in this case, we're gonna have 1, 2, 3 over here, right? And then we're gonna have a propane. But also we have the hydrox group, carbonyl groups and the hydrogen over here that makes aldehyde form, which is R, this one. So you have this. So this will become propanol. Okay. So this is a quite simple rule you can apply to when you name the this one. Okay. So maybe can you guys try this one? Here. Maybe you can try this one. So we have a 1, 2, 3, 4, 5, okay? And you have a 2 prefix. Okay? And maybe you can try to use your knowledge for what we learned, and just use the AL. You might get the name for this one. Okay. Okay, about 1 minute. We'll do this together. Don't worry about it. Just try it on your own first, and we can compare. That make more sense then. Okay, about 30 seconds. Okay, so if you do this one here, we have 1, 2, 3, 4, 5, or it doesn't matter 1, 2, 3, 4, 5. Your longest carbon chain, right? So we're gonna do pentane, but we're gonna put A over here, and then obviously this is your functional groups. So we'll count the carbon from here. 1, 2, 3, 4, 5, and you have a 2 methyl group here, so it will be dimethyl pentanol, but you have a position 3 and 4, so that's okay. Perfect. So this was, I think, was quite okay. So I'll just move on. Okay. So there's another thing you can do is if you look at this R, C, with the double bond oxygen, this the aldehyde groups over here. We call this the CHO group. It just because the 1 carbon, 1 oxygen, 1 hydrogen over there. So whenever you have this aldehyde groups over here, CHO group over here, what you can do also is you can name this one first, this R part, and this is your CH group over here. And then you're just gonna put the, this is, so we named this separately first. So this will be 1, 2, 3, 4, 5, 6, so the hexane, right? But in the ring structure, I'm gonna put cyclo. This is cyclohexane, and then you have the CH group over here. Then you just need to say carb CARB aldehyde. That's how you can name it too. So this will be cyclohexane carbaldehyde. Okay. So another thing, does it make sense? Make sense, right? So another thing you can possibly do with the other example. So this is naphthalene that we learned in the conjugate compound, right? And naphthalene has a maybe what's a CH group here. Okay. Maybe I can just write this structure over here. Okay. And then you can say, oops, naphthalene, and then what? Same, carbaldehyde. So naphthalene carbaldehyde. So it's the same thing here. So you actually name these two parts separately and just combine with this CARB. Okay, it's carbaldehyde. So maybe can you guys try this one? Okay, maybe you can do the same. Try to name these two separately and combine with the CARB between. About one or 2 minutes. Okay, so we're gonna name this one. It's benzene carbaldehyde. Okay, makes sense, right? Okay, so if you guys remember this is what we learned before benzaldehyde. So benzaldehyde is like a shorter name for this one, benzene carbaldehyde. Can I move on? Okay. So how about ketone? Okay. How about ketone? Ketone here, we're gonna, so the aldehyde we use Al. Ketone we're gonna use O and E because it's the last three ketones. So if you have, oh, one more thing I forgot to mention. So aldehyde is always what? With the carbonic groups with the hydrogen with R here, right? So you don't have to number the location because the aldehyde is always going to be end. So we don't number the location of the aldehyde, okay? Yeah. Kind of common sense, but just making sure. But for ketone, you have to number it because you may know where the ketone if you don't show on the name, okay? So maybe we can do this one. So first thing, it's pretty much the same. You're gonna find the longest carbon chain. So it would be 1, 2, 3, 4, 5, 6. So it would be hexane. But here, once again, instead of last E, we're gonna put what? O and E. So hexanol. So because it says ketone, so ketone is, it looks like you have a carbonic groups with 2 R. So 1 R, 1 hydrogen would be aldehyde, but 2 R will make T ketone. So this is ketone because it has a 2 R groups on this carbon. So in this case, obviously you want to count the carbon from here to give the lowest possible number for the location, looking for the hexagon here. So you can say 1, 2, 3, 4, 5, 6. So you can say 3 hexagon. You can also do hexane 3 non, that's fine. It's mirror name system, but I really don't care. So either you can do right way for the local number and the loss O and E for ketone compound will be just fine. Okay, how about this one? Okay, so wherever we have this one. Okay, so you have the ketone carbonic groups with also the double bond there. So in this case, we're gonna care about this one much more than this one. So in this case, we're gonna count the carbon from here. So this is more important for us to name the compound. Okay. So there'll be 8, right? So it'll be octanon. Okay. And then you can actually do this one. Okay. So tenone. Okay. So in this case, what you can do is this is number 2. This is between what? 5 and 6, right? So we're gonna choose number 5. Okay. Makes sense, right? And then this will become what? Oc 5 in, which means your double bond, and 2 on. 2 on. This is the location for what? Your ketone. This is the location for your yeah. So does it make sense? Okay. Can you guys try this one? Maybe you can try this one. Okay, real quick. Okay, about 1 or 2 minutes. Okay, so yeah, it's just 10 more seconds. Okay, so yeah, same, right? So we 1, 2, 3, 4, 5, 6. So this is our longest possible carbon chain. So I'm gonna do hex, but we're gonna do what? We're gonna do number the carbon from here. Is it here or here? Is it 1 and 2? Which one we're gonna choose? 2, perfect. So 1, 2, 3, 4, 5, 6. So the location for your carbonic group in ketone should be 2, and this is in between 3 and 4. So location for this one would be 3, because I choose always the low one between 3 and 4. So it would be hex 3 in. So in means what? Like E and E, like a double bond, and then you're gonna have a 2 O and E 2. So it would be hex 3 in 2 on. Okay. It's kind of weird name, but yeah, it's the way it is. Okay. Can I move on? Okay, perfect. So this is a very good example. You can try. There's just a few more things you can. Here, you keep it 2. Only difference is you just put dione, okay? Because it's the 2 ketones, right? And you just need to put your carbon chain 1, 2, 3, 4, 5, 6, 7. So we have heptane. So in this case, I'm not gonna remove the E. Do you know why? Because it's hard to pronounce. Because you have an N and D. How are you gonna pronounce it? So keep the vowel sound there in between. So I'm just gonna keep the E there. So it's better for trione, dione, so on. Because you have a much easier way to pronounce the compound. Okay. So we'll move on. Okay. All right. So that is the case. There are a couple of things to mention here. This is some name of the compounds, the groups. This is what we call AC group. This is the acetic group. And then there was there's a 4-mel group. Okay, and this one is the benzoyl group. So there's a type of a thing kind of want you to remember. We may use quite a lot in this chapter. It's an AC group. We learned this when we learned acylation. So the carboxylic groups without that, the hydroxide groups is the AC part. And this is one example of AC group. But it's quite common, so we use this name. And if you have some like a, sort of like a CHO group, like an aldehyde group, like it's 4-mel groups, and then if it's also kind of a benzene ring, but that's the carbonyl groups. That's what we call this benzoyl groups of it. So let's try to remember this one for this chapter. All right. So let's try to. I'll show you one. So let's talk about the chemical reaction here. So what I'm gonna do is I'm gonna have some ester compound over here. I'm gonna treat it with the DIBALH. This is diisobutyl aluminum hydride. Okay, and some acidic condition here. So this is what it looks like. So we have okay. So this is it's isobutyl group, but there are two. Okay, so we dibutyl aluminum hydride because the hydrogen on this aluminum. So aluminum now are kind of doing a 3 around it because it's a group. Okay, so in this case, what happened to this one here is this. If you treat it with the carbonyl groups over here, they're going to have interaction. Okay. And then they're going to have attack over here. So this will become positive and negative, right? Okay. So the one over the lone pair and this the oxygen and carbonyl group goes to aluminum, and then this is enough push to make this one goes to here, this hydrogen. So hydrogen and this from the aluminum will attack on the carbon here. Okay. So if that happens, it goes to over there. Okay. And then yeah, and then this will be also donated from. Oh, I didn't have to remove it. Sorry. So that goes to also in a push down with this donation here, and that makes. Okay, sorry. I'm going to show you. This one now is gone, right? It's so hard to show you step by step, which you don't have to know the mechanism, but this carbon now wants to have a hydrogen here. This double bond will be gone here, and there's another one coming here. It's making double bond again, but that makes enough push to this one to leave. This group will leave by donating this one. Yeah, sorry. So then this was gone to here. This aluminum with the top butyl with positive charge, and once that detects that this one goes to there. So this is the outcome after chemical reactions. But the thing is what? They become so you have an aldehyde now from the ester group. Let's try the problem. So let's do this again. So can you guys maybe make it sure? Can you guys try this one real quick? So only thing you have to do is try to turn your ester group to the aldehyde by using this one. But yeah, you can try this one first. We'll do this together again. Okay. So we'll become aldehyde. That's the point. Okay. So yeah. Okay, so yeah, let's do this one together. Okay, so the trick is here. So you have a ester group over here, right? And then try to remove the ether group like away. Just remove it and replace by hydrogen. That's it. That's the trick. Okay. So if you have you have the aluminum aluminum hydride with acidic condition with a bit of a toluene solvent. You have some ester group here. I just remove it and replace by hydrogen. So now you have a aldehyde compound. Okay? That's the trick you can do. Obviously, you don't have to worry about the mechanism, but this is what it does on the ester group over here. Okay? So let's do another one. So if you have a alcohol compound over here, I'm going to treat it with the chromium trioxide in some organic solvent molecule. And then what happens to this one is this one. Okay? So you have this one over here, and also it happens in the bit of acidic condition here. So what happens here is they grab this one. So one of the lone pair in this oxygen will grab this one of the hydrogen cation, and then they become this, okay, with water. Okay, it comes in over here, and then what happens to this oxygen here and this hydrogen group will attack here, okay. And then this will make so this if that attacks when there's only one lone pair, right? The 1 and 2, it goes to there. So this will goes to this. Okay. And then there's another water comes in. Okay. Another water comes in, and then they try to grab one of the hydrogen over here. Okay. And then this will also grab this hydrogen over here. Okay, and then they will be gone, right? Will be grabbed by this one, so it'll be donating by this one, and that moves to stabilize this one. It's gone, so then it will become negative charge with this one goes down there. It becomes carbon groups. So you have this one. But from here, but they sometimes just detach this, so they just become anion with the 2. Okay, so okay, so and also there's a there's a push here when it has a pick up by this one. Okay, when you have this originally the hydroxyl group, there's a implied hydrogen there. This will also be attacked by water, and that's why the inner push to make a carbonyl groups, and this is moved. Okay, so yeah. Do you want me to explain this again? Or does it make sense? So yeah, the thing was when they come up with the hydrogen cation, that when water grabs it, there's implied hydrogen will be also attacked by the water. So when it has a neutralized, once it's positive neutralized, attack, that goes to there, and that makes push to this one to just leave again. Okay. Yeah, I'll just stop here. But anyway, okay. So the thing is, the key point here is this one. So whenever you have a alkyl group over here, right? When you're trading with a very strong oxidating agent here again, you just need to remove the hydrogen and the double bond there. That's the trick. Okay. This is what happens to the compounds. Okay. So if I give you some compounds with the hydroxyl group, which is your alcohol, treating with a quite strong oxidizing agent here, you just need to keep everything same and just change this to carbonyl groups. Okay? That's it. So this is a trick we can do. All right. So okay, maybe you can try this one. Okay, let's try this one real quick, and we'll move on. So the trick is pretty simple, right? So you see the alkyl compounds, you see the hydroxyl group, just change it to the carbonyl groups. That's the only thing you have to do with this the chromium trioxide. Okay. Somebody closed the door. Was it already closed?
No, they were
They were-
some who were cleaning.
Oh. Okay, so it's pretty simple, right? So we just need to copy everything. And I'm gonna change this hydroxyl group to carbonyl groups down there. So you have a bit further oxidation from the alkyl compounds with the chromium trioxide. Okay, it's a pretty simple trick, right? So can I move on? Okay, good. So let's try one more. All right, so there's actually something that is quite similar to us, is what we can do with the ozonolysis. Okay? So if you have something looks like this, you can treat it with the ozone with a bit of zinc. Okay. This is So if you try to do this here, if you remember the trick we did for the ozonolysis is where you have the double bond, just try to cut this in half. Okay. So I'm not gonna do ozonide mechanism. You probably remember this one, but obviously the trick is just break this one in half. So there's carbon here, right? So I'm gonna do. And when you break it, just put 2 oxygen over there, here and here. So we'll come this to this one, because there are 2 implied hydrogen here, right? Then you try to do this one. So you can try to make the aldehyde one, and also this is a methanol, right? Methanol. This is only 1 carbon, methane, but we're gonna put it as a aldehyde, so methanol over there. And because of this one, do you remember this one? this is a forming group. You can also call this formaldehyde, because it's forming group aldehyde, formaldehyde, which is the same as what? Methanol. Okay. Do you guys actually remember this one from Organ 1? Ozonolysis, it's cut in half and two carbonyl groups through the malozonide and ozonide. So anyway, does it make sense? You want to try? Let's try it. Trying to make. Can you guys try this one real quick and we'll move on? Yes, just real quick. It's pretty simple. You just need to cut in half and double bond in two carbons and put the oxygen on each. That's it. Okay. That's the job. Okay. Just make sure you have some implied hydrogen there. That's the kind of part, but you know that there's hydrogen because there's carbon. Yeah. Okay. Perfect. Yes. Perfect. All right. So move on. Okay. So just several tricks we can do for this type of forming aldehyde. How about ketone? Okay. So we have a very familiar direction we already learned in previous chapter. You can do with the this one. So you have our maybe acetic chloride over here, and you can treat it with some aluminum trichloride over here. Okay, so this is what we do with the aromatic, electrophilic substitution reactions. So this will too, once again, become aluminum tetrachloride negative, right? And then this will become iron, which is susceptible by this attack. So will become this will be gone. And this is now added on the ring. So this hydrogen will be picked up by this one. So this gets again. So it's just the substitution reactions we did before. So now we have what? Ketone. It's R over there. So this is the reaction we could use where we already learned from previous chapter to make the ketone by just doing a substitution reaction. Okay. All right. So let's move on. There's the next one. Okay, I'll just let me stop here today. Okay, I don't